Hi, welcome to another example in my series on how to solve trig equations by using identities. Now, in this example we've got to solve 3 sine x over 2, or a half x, plus cos x equals 2 for x between 0 degrees and 360 degrees inclusive. So, how do we solve an equation like this? Well, the first thing I notice is that we've got different angles, x and a half x. And I also notice that this angle is double this angle. And generally, it's a good idea to try and aim to get the same angle in a trig equation. It's not always possible, but in this one it is, because this angle is double this one. And when that happens, you can often use what we call the double angle identities. And this angle is in the cosine function here. So therefore, I'd be looking at the double angle identity for cosine. And you should know this, it's cosine 2a is identical to cos squared a minus sine squared a. If you don't know this, try and learn it, but you'll generally find it in some formula books. The thing is, there are two other versions for this identity. We can have 2 cos squared a minus 1, and we can also have 1 minus 2 sine squared a. Now if I let 2a be the angle x, let's just put this down here, 2a equals x, then if I divide both sides by 2, I get that angle A is a half x. So that means that instead of 2a, I can say that cos x, because 2a was x, is identical to cos squared a half x minus sine squared a half x, or 2 cos squared a half x minus 1, or 1 minus 2 sine squared a half x. The question is, which one do I choose? Well, it's also a good idea to try and aim to get your equation in the same trig function. And because this term here contains a sine term, then it would be a good idea to get this equation all in terms of sine. So of these three identities, I want to go for this one down here. So cos x becomes identical to 1 minus 2 sine squared half x. So if we use this identity, substitute 1 minus 2 sine squared x upon 2, in here we will get the following: 3 sine x over 2 for the first term, plus, now we make the substitution, 1 minus 2 sine squared x over 2, and that equals the 2 on the end here. So what we've got is an equation, a quadratic equation in sine x over 2. Now, like all quadratic equations, we need to rearrange them into the form where it equals 0. So I'm going to make this term positive by adding it to both sides, and so therefore I would get 2 sine squared x over 2. I'll now follow with this term by subtracting it from both sides, so it becomes minus 3 sine x over 2. And then I need to subtract 1 from both sides, so 2 take away 1 leaves me with 1, and that equals 0. Now, this particular quadratic equation factorizes, so I'm going to factorize it, couple of brackets, equals 0, and what we have is 2 sine x over 2, sine x over 2 there, and then I've got a minus 1 and a minus 1. You can check that out, it expands out to give me that. Now that I've factorized it, it means I can put either factor equal to 0. So we've got the first factor equal to 0, now we've got the second factor that we can write equal to 0. Now when we look at this first equation, we can rearrange it to make sine x upon 2 the subject by adding 1 to both sides and then dividing by 2. So we get sine x upon 2 equals a half, Or with this one, all we need to do is just add 1 to both sides. So sine x upon 2 equals 1. Now, if you weren't happy about factorising your quadratic, then you could use the quadratic formula. And here we have a quadratic equation in sine x upon 2, so it would be that sine x upon 2 would equal, and the quadratic formula is minus b plus or minus square root then of b squared minus 4ac all divided by 2a, where a, b and c can be found from here. A is 2, b is minus 3, c is 1. If you had substituted those in there, then you should have worked out that sine x upon 2 is a half, or sine x upon 2 is 1. So, okay. Either way, we end up with these equations then, and we need to solve them. So what I'll do is I'll just move that up to the top now and leave us with our two equations that we need to solve. So let's start with when sine x upon 2 equals a half. So to get x upon 2, we take the inverse sine of both sides. So x upon 2 equals the inverse sine of a half. And make sure your calculator's in degrees mode, because we want solutions between 0 and 360 degrees. And if you inverse sine that on your calculator, you should find that you get 30 degrees. Now to find the other solutions in the range 0 to 360 degrees, you can either draw a graph, or I prefer, for something like this, the quadrant diagram. So we've got a quadrant diagram, 0 degrees here, 90, 180, 270, 360 in the usual way. We've got sine of x upon 2 is a positive number, positive a half. So where is sine positive? Well, it's positive in the first quadrant and in the second quadrant. Draw two lines equally inclined to the horizontal, marking those two angles always. Now, where are the solutions that we want? Well, the first solution starts from here, goes to the blue line. Don't mark it in as x, it's a half x. Okay, that's a place that people often trip up. Start again here, turn round anti-clockwise to the next blue line, and this is another possible x over 2. Now, when we inverse sine a half, we got 30 degrees for x over 2. Well, that's clearly this red one here, and the red one is the same as this little blue angle in here, so that's 30 degrees, which means that this one over here, this little blue angle, is 30 degrees, and that will help us get the green one now. 180 minus 30 gets us the green one then, and that's going to be 150 degrees. Now if we multiply by 2 to both sides here, we get what x is. X is 60 degrees and 300 degrees. Alright, so they're the two solutions then for when sine x upon 2 equals a half. Let's go on to the next one, when sine x upon 2 equals 1. So again, to get x upon 2, we take the inverse sine of both sides. So we've got the inverse sine of 1. And if you get on your calculator, you'll see that that comes out at 90 degrees. So are there any other solutions? So let's just have a look. This time I'm going to draw a graph. I prefer to draw a graph for these basic ones when you get 1 or 0. So let's think about the graph. Y equals sine x. Sine x, it starts at the origin, rises to 1 at 90 degrees, back down to 0 at 180, negative 1 at 270, and back to 0 at 360. So it's 1 at 90 degrees, and that's the only time over the interval 0 to 360 where it is 1. So that's going to be our only solution, because when I now times by 2, we get that x equals 180 degrees. So all that remains to do is just to put the answers in ascending order. So we get 60 degrees, 180 degrees and 300 degrees. Okay, so that brings us now to the end of this example. So always look out in your trig equation if one angle is double another angle, because quite often that means you can use the double angle identities.